In a previous video, Sprint Actions of the Dog, we covered the structural and muscular actions that occur when a dog is running in a straight direction or straight line. In this video, we will cover the structural and muscular actions that occur when a dog is turning. The body uses various muscles to alter the direction of movement. These directional changes place many different forces upon the dog's structure. It will also cover the paw-to-surface interaction. The paw is typically the point of surface contact for the dog's body and plays an important role in locomotion and structural function. The paw must have a firm grip on the surface for the body to manage the forces needed to make the turn. This video of Hannah navigating a turn was captured at a rate of 240 frames per second. It is being played back at a rate of 30 frames per second. This allows us to view the actions of the body to counteract the forces needed to alter the body's direction. It is a good example of Newton's first law of motion, where an object will remain at rest or constant motion unless a net force acts on it to change this motion. In this scenario, the muscles are creating the forces needed to change Hannah's direction to the left. Similar to straight running, the core energy of running is created by the rear end, but when turning, the front legs create lateral forces to direct the dog's body in a different direction, away from the line of travel. This results in a change of direction. To make the turn, the dog will orientate the body towards the direction of the turn, in this case to the left. It needs to create the centripetal forces to make the turn. They will move the front legs outside of their center of gravity. This allows them to push the body away from its original force direction. The outside front leg plays the most pivotal role in the turn. That's why when someone talks about their dog not handling a turn, the first place to evaluate is the outside front limb. Then the rear legs land and continue to create propulsion. During this time, the core muscles of the axillary structures contort themselves to position the rear limbs to assist in the directional change and to create the next propulsion action. This effort is continued to maintain the turn. A very important component of this action is the paw-to-surface interaction. This applies a lot of stress to the distal limb and paw. The paw must provide traction to keep the body from slipping, and at the same time it must absorb the forces of impact and propulsion. The paw structures of the dogs are very complex. There are many bones held together by ligaments, and it is stabilized by the tendons of the digital musculature. The paw pads are the dermal structures that provide most of the tractional surface and cushion. The nails can play a role, but a short nail is crucial. The longer the nail, the more the forces are transferred to the bones of the toes and ligaments of the distal structures. This video is of a greyhound making a turn, but the force actions are the same for all dogs.